Hello everyone and welcome to day 20 of the Jamb Physics in 40 Days series. The Jamb Physics in 40 Days series is brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you'll be able to get all the necessary skills and tools that will help you ace Jamb Physics. So peradventure, you're preparing for the Jamb exams and physics is one of the subjects you have selected in your subject in the subjects that you've chosen for the exams, then this video is definitely for you. So please trust me, you do not want to miss any of the videos in this series. We've done well to look at different topics that are in the Jamb Physics curriculum, and then we explain them in the different days in individual videos. So for example, in day 1 we have a different topic there from what we have in day 2 and then in day 3 and so on. This is why you don't want to miss any of the videos in the series, because not only do you get to learn the different topics that are in the Jamb Physics curriculum, we also give you a crash course to it, as well as some tips that will help you understand some of the facts in those different topics, and then we go on to solve past questions in those topics. So don't miss it. Check it out from day 1 up until this day 20. And trust me, once you're able to go through the entire series, you will definitely ace Jamb Physics. Now, also do not forget to share this video amongst your friends who are also preparing for the exams. You also want to help them to do well. So please share the video, like the video, and don't forget to subscribe to the channel. We need you to subscribe to the channel so that we can keep making more helpful videos like this. So please hit the subscribe button and click the notification bell icon so that you get alerted every time we put out a brand new content for you. Now, day 20 is about waves. Now, waves in physics is defined as a disturbance that transfer energy from one point to another without there being a permanent displacement of the particle of the medium. Now, as far as wave goes in physics, there is a very broad topic in physics. So, but Jamb has been able to break it down into different segments. So, for this one, what we are going to be looking at is what we have highlighted here. Now, mind you, there are other aspects of waves that we are still going to look at in subsequent videos. But as far as this video goes, we are looking at what is in the curriculum for waves according to Jamb. The first part of it says that we have to consider the production and propagation of waves. And what this means is that you must be able to define what wave is, you must define wave motion, and be able to define the relationship between the frequency of a wave, the wavelength of a wave, and the wave velocity. There is a relationship, and that relationship says wave velocity v equals to the product of the frequency of that wave and the wavelength. You should also be able to define these things too. Like for example, frequency is defined as the number of cycles a wave completes in 1 second, while the wavelength is roughly defined as the distance between successive crest or trough of a wave. But another way to look at it is at the distance traveled in 1 cycle of a wave. So be able to define all of this and their relationship. And not just that, you should also be able to use the equation of a progressive wave to solve problems on waves. And the equation of a progressive wave states that when you are looking for the y component of a wave, it is equals to the amplitude multiplied by the sine of, then we have wt minus kx. Now, this can be written as y equals a sine. Now, this is plus or minus actually. So, sine, then 2 pi ft plus or minus 2 pi x over lambda. Now, this is the equation of a progressive wave. So you could find some question where they give you a different equation to a progressive wave, and then you compare it to any of these equations, and from there you should be able to find things like wavelength, frequency, angular velocity. You should also be able to find quite a lot of things that we see, even the amplitude of the wave. You can get it using this equation of a progressive wave. Now, not just that, Jamb also expects that every candidate should be able to classify waves accordingly. Now, when we're looking at the classification of waves, we look at things such as mechanical waves and electromagnetic waves. There are so many questions you can find there. Now, one thing that actually differentiates mechanical waves and electromagnetic waves is that mechanical waves require material medium for their propagation, whereas the electromagnetic wave does not require this material medium for its propagation. Now, other things that you may also bear in mind in this case is that for electromagnetic wave, all light waves are electromagnetic in nature, right? So, and then you should also be able to tell them apart, give examples of mechanical waves and examples of electromagnetic waves. And another classification we also look at is things like transverse wave and longitudinal wave. So that's when you are looking at the classification of wave based on the direction of the wave motion and the direction of the particles of the wave. So when the particle is moving in the same line, that is, they are parallel to the direction of the wave itself, the particles and the waves are parallel to each other in direction, that will be a longitudinal wave. But when they are perpendicular, that is, the particles are moving at 90 degrees to the direction of the wave, that is an example of a transverse wave. So, and beyond that, you should also be able to tell what we know as stationary wave and progressive wave. Now, the difference there is that for a stationary wave, energy is not transferred from point to point, but progressive wave transfer energy from one point to the other. Now, that's the case for classification of wave. And then finally, they expect that you should be able to give the characteristics or properties of waves. Now, one of those characteristics or properties are in the case of reflection, refraction, diffraction, interference, and polarization of wave. But please take note, polarization is only the characteristics of light wave. It does not characterize any other wave except for light wave. This means that only light wave can be plane polarized. Every other wave exhibits reflection, refraction, diffraction, and interference. But only light wave exhibits polarization, or what we call plane polarization. Now, beyond this, you're also expected to be able to understand superposition of waves, which is based on interference. When two waves of the same frequency and wavelength interfere with one another, superposition occurs. And this can be either destructive or constructive. Now, it is destructive in the sense that when they interfere with each other in such a way that they cancel out and you cannot see the effect of any of the wave, the amplitude becomes zero. That will be destructive superposition. But when the amplitude is increased after they interfere with each other, then what you have in that case is a constructive superposition of wave. Now, you should also be able to define what beats are, and it's also a case of interference. But in this time, you see that the waves do not have the same frequency, they don't have the same wavelength. They are close, but not exactly the same. Now, when they interfere with each other, you now begin to see this rising and dropping tone. You know, that kind of things you see when you listen to music, where there's a fluctuation in the tone. It's moving loud and low, loud and low, loud and low. So it's the same thing in this case. So in physics, we call it beats. Okay, probably I don't know whether it is the physics that led to us calling it beats even in music, or it's vice versa, but they are called beats. Now, you should also be able to explain Doppler effect also, which is what you experience when a particular sound wave is moving in motion. So it's either the observer is stationary while the wave is in motion, or the observer is moving while the sound source is stationary, or both of them are moving. It's just kind of like what happens when you are by the road and then perhaps an emergency truck is coming by and the siren is, blaring loudly. You hear it initially very faintly, and then as it's approaching you, it becomes louder and louder and louder, and the moment it goes away from you, the sound begins to fade off like that. That explains what we know as Doppler effect, and you should be able to use this to also calculate either frequency, wavelength, distance, and the likes as far as wave goes. Now, folks, this is just a crash course to what we have been talking about. It's a whole lot more deeper than this. So we expect that you should be able to study more on this And to help you, you can check out our videos where we explain wave motion in greater detail. This one is just for the sake of preparing you for JAMB exams. So for deeper understanding, please check out our videos on wave energy. I promise you, you will get a better understanding of it after that video. But for the purpose of JAMB, we just need to highlight this and then go on to solve some past questions that touch on each of these things that we have mentioned. So please get your materials ready and let's solve some past questions. And do not forget, if you have any question concerning this video at all, or if there's anything you find during your time of study and you want us to shed more light on it, please drop it in the comment section. I will definitely attend to it. But for now, let's go solve some past questions. Which of the following statements are correct of the production and propagation of waves? Now, statement 1 says vibration produces waves. And since waves is a disturbance that transmits energy, then it is caused by vibration of a medium. So yes, it causes waves. So 1 is correct. Now, statement 2 says waves transmit energy along a medium. Still part of the definition for wave is a disturbance that transmits energy from one point to the other in a medium. So definitely 2 is also correct about production and propagation of wave. Now the third statement is that the medium through which the wave travels does not travel with the wave, which is also part of the definition of production and propagation of wave, where we say that a wave is a disturbance that transmits energy from one point to the other without permanent displacement of the particles of the medium. So that is, the medium does not travel with the wave. So statement 3 is also correct about the production and propagation of waves. Now 4 says waves do not require any medium for transmission. Now this is only true for the electromagnetic waves. They are the ones that don't require any material medium. But mechanical waves require material medium. In fact, one of those very important waves that require material medium is sound wave. Like you are able to hear me now, because the air molecules around is able to carry the energy from my sound all the way to you. So you see that waves actually require material medium for their transmission, just that it is not for all types of waves. So the statement 4 is not absolutely true for production and propagation of waves, whereas 1, 2, and 3 are absolutely correct. So we're going to go with the option that gives us 1, 2, and 3, and that is option D. Which of the following characteristics of waves is used in the measurement of the depth of the sea? Now, to measure how deep the sea is, or to find the distance of the seabed, what they do is they will blast sound waves to the bottom of the sea. Now, expecting that once it hits the bottom, it's going to reflect all the way back. So all they do is now measure the time in which it takes that wave to go from the ship to the bottom and then to be received back at the ship, right? So by using that and the speed of sound in water, you can use that to determine the depth of the sea. So you see that what is used there is a reflection. So our answer is going to be option D, where we have reflection. Any line or section taken through an advancing wave in which all the particles are in the same phase is called, let's consider we have multiple waves like this. And then you take a line that cuts like this, such that this point, and this point of the individual waves there are the same phase. Now, this particular line here is called the wave front. So that means the answer in this case is option D. A vibrator causes water ripples to travel across the surface of a tank. Now, the wave travels at 50 centimeters in 2 seconds, and the distance between successive crests is 5 centimeters. Now we are to calculate the frequency of the vibrator. Now, since this is in centimeter and this is also in centimeter, that means I don't need to convert into meters. I can work with the same units. So using this, we can be able to find the wave velocity. So here's the solution. First, we need to find the wave velocity. The wave velocity is supposed to be f lambda, and this way we can get frequency. But we know that the same wave velocity is supposed to be distance or displacement over time. So let's apply this. So v equals, the displacement is 50 centimeters, the time is 2 seconds, and this would give us 25 centimeters per second. Now, let's find frequency. Frequency therefore becomes the wave speed divided by the wavelength. Now, the wave speed is 25 centimeters per second, while the wavelength is the distance between successive crests, which is given as 5 centimeters. So we see centimeter cancels centimeters, and 25 divided by 5 is going to give us what? 5 per second, or 5 hertz, which is the unit for frequency. So since the answer is 5 hertz, that is option A. Which of the following is not a mechanical wave? Now, before I answer this question, if you have any question at all for us, perhaps concerning the video you're watching, or if it's based on what you've seen while you are studying, maybe a question you're trying to answer and you need help with, please put it in the comment section. I will definitely attend to all of your comments. And also don't forget to like, share, and subscribe. It's really important to us that you subscribe to the channel so that we can continue to make more helpful content like this. So please subscribe. Please share the video amongst your friends. Let's reach so many people so that we can help more people become better at the physics, math, and so on. So please keep sharing, keep subscribing. Thank you very much. Now, this question says, to answer this question, we are trying to pick out which of the following is not a mechanical wave. So we must understand what a mechanical wave is. And at the beginning of the video, I did mention that we have different types of waves. They are classified either based on their need for material medium as either mechanical or electromagnetic waves. Now, I mentioned that mechanical waves are those that require material medium for their propagation, and the electromagnetic waves are the ones that do not require material medium for their propagation. Now, while it might seem a little bit difficult for some to be able to identify which one is electromagnetic from which one is mechanical, one easy way to do this is just to identify electromagnetic wave. And then any wave that does not belong to the electromagnetic spectrum can then be classified as mechanical. Now, a simple way to know those waves in the electromagnetic spectrum is to use the acronym REVOX-G. Now, this is what I mean. REVOX-G. However, to add to this, there's another one called the microwave M. So this M means microwave. Then we have the radio wave. Then we have infrared. Then we have visible spectrum. We have the ultraviolet. We have the X-ray. And then gamma rays. Okay, now all of these are the electromagnetic wave because they belong to the electromagnetic spectrum. So they do not require material medium for their propagation. Now, any other wave you know that does not belong to this is then mechanical in nature. So like waves in closed pipe does not fall here, so it is mechanical. Water wave is not here, so it is mechanical. Sound wave is not here, therefore it is mechanical. So the one that is not mechanical is radio waves, which we find in the electromagnetic spectrum. So our answer is going to be option B. A radio station broadcasts at a frequency of 600 kilohertz. If the speed of light in air is 3 times 10 raised to the power 8 meters per second, calculate the wavelength of the radio wave. Now, with this, I have to mention that one of the major differences between electromagnetic wave and mechanical wave is the speed at which they travel. Now, the speed of electromagnetic wave is the same as the speed of light, which is what is mentioned here. And the speed of mechanical wave varies. Like speed of sound, for example, is within 320 meters per second to 340 meters per second, depending on the medium through which it is traveling. Like in air, it's usually 340, in water it is different, and so on like that. And when you compare this to other waves, they have their own speed. But the speed of light is about 3 times 10 raised to power 8 meters per second. So please bear that in mind in case you come across a question requiring to find based on the relationship of speed, wavelength, and frequency. Always know that the speed of light is approximately this value that we have here, and it is the same for all electromagnetic wave, whether it is radio wave, whether it's infrared, whether it's no matter what, which of the electromagnetic wave, as long as it is in the electromagnetic spectrum, we approximate it to the speed of light, except if the question gives you a different value, but this is what it usually gives. So now let's go on to solve this question. We already have the speed. Now speed of light is not denoted V, it is denoted C instead. So when you see C like this, know that it is speed of light, 3 times 10 raised to power 8 meters per second. And then we are given the frequency F as 600 kilohertz. Now, what does this mean? This means we have 3 and then 1, 2, 3, 4, 5, 6, 7, 8 meters per second. And this means we have 600. Kilo means times 10 raised to power 3. So that's 1, 2, 3. And that is in hertz, which is the same thing as per second. Now, let's find wavelength. Wavelength would then be speed of light over frequency. So we have 300 million divided by 600,000. So 0 cancels 0, and we continue like that. So now we have 3,000 divided by 6. That will give us 500. And wavelength is measured in meters. But all the answer that we have in the options are in standard form. So bringing this to standard form, we have 5 times 10 raised to the power of 2 meters. And that is what we have in option B. So our answer is B. The frequency of beats produced when two tuning forks of frequencies 258 Hz and 270 Hz sounded close to each other. So to find the frequency of the beat, when you have the individual frequency of the sources of the sound, is the difference of this frequency. However, when you don't have the frequencies, you have to first find their individual frequencies and then find the difference. So in this case, since we already have the frequencies, we can go on to find the frequency of the beat. So the beat frequency is going to be the difference of their frequency. So the larger minus the lesser. So let's say that to be F2 minus F1. So F2 is 270 Hz, while F1 is 258 Hz. Now the difference here is 12. So the beat will have a frequency of 12 Hz, and that is in option D. Which of the following statements about wave motion is correct? So I'll be taking us through the options and then we see which one is correct and why it is correct as compared to the others and why they are wrong. So that by doing so, we'll not only know the answer to this question, but also learn a few things in case if the question were to be turned around. So let's look at it. Option A says electromagnetic waves are transverse. Now, this is one of those differences between electromagnetic waves and mechanical waves. You can make it a point of assignment to go through all the differences between electromagnetic waves and mechanical waves. We've mentioned one earlier where we said electromagnetic waves travel at the speed of light and the speed at which mechanical wave travels varies, right? Now, this is another one. Electromagnetic wave. All electromagnetic waves are transverse in nature, right? But mechanical wave can be transverse or longitudinal, right? So, but all electromagnetic wave, whether it's microwave, radio wave, infrared, visible, ultraviolet, X-ray, gamma ray, they are all transverse in nature. Now, what that means is that the wave particles travel perpendicularly to the direction of the wave. So, option A is a correct statement about wave motion. Now, let's look at option B, C, and D and why they are not correct. Now, option B says transverse waves do not require material medium for their propagation. They do not require a medium for propagation. Now, we did mention that electromagnetic waves are transverse in nature, and electromagnetic waves do not require material medium for their propagation. But we also have other transverse waves that require material medium. One of them is water wave. Water wave is transverse, and it requires the molecules of water for its propagation. So it needs material medium for propagation. So this is not correct. Now, C says longitudinal waves vibrate perpendicularly to the direction of the travel. Now, this is false because it is transverse wave that travel perpendicularly to the direction of the wave, but longitudinal is parallel to the direction of the wave. So C is also wrong because of that. Now, for D says all mechanical waves are longitudinal. No, because mechanical wave can be longitudinal and it can also be transverse. For example, water wave is mechanical and it is transverse in nature, but sound wave is mechanical and longitudinal in nature. So you see it there now. This is why D is also wrong. So back to option A, which we have chosen as the answer. So we just record our answer as A. Electromagnetic waves are transverse. The compressed regions and spaced out regions in longitudinal waves are referred to as. Now, before I answer this, let's also look at the case when we are looking at a transverse wave. In the case of a transverse wave, we have some things that are called crest and trough. While the crest is where you have the maximum displacement, and the trough is where you have the minimum displacement. Now, just as we have that characteristics in transverse wave, there is the same thing in longitudinal wave, but this time they are looking at how close the particles are together or how spaced out they are. So when they are close together, it's considered the compression region. Then when they are spaced out, it is considered the rarefaction region. And when there is no displacement at all, where that point is called the undisturbed region. However, we don't really talk much of that because when you are looking at the wave in longitudinal, we are concerned about where there are compressions and where there are rarefaction for longitudinal wave. So the answer is in option A, compression and rarefaction. A stroboscope can be used to make the wave appear dash. Now, the stroboscope is an instrument used in the physics lab to make a wave appear stationary. So the option we'll go for here is A. From this question, we're given the distance between two successive crests as 15 centimeters for a wave. And then the velocity of the same wave is given as 300 meters per second. And we are asked to calculate the frequency. Now, it's important that we bring either these to meters or bring this one to centimeters per second because they have to be in the same units to solve this problem. So I'll prefer to bring these to meters. So let's solve. It means the wavelength, which is the distance between successive crests, that is given as 15 centimeters will now be 0.15 meters. And then we're given the wave speed v as 300 meters per second. So now frequency will now be the wave speed, which is 300 meters per second, divided by the wavelength, which is 0.15 meters. So meters cancel meters. Per second is the same thing as hertz. So we now do 300 divided by 0.15. This can be written as 30,000 divided by 15 hertz. Now 15 here 1, 15 here 2. So what we have is 2,000 hertz. So 2,000 hertz is 2 times 10 raised to power 3 hertz. And that is option C. The equation of a wave traveling along the positive x direction is given by, and then we're given this y equals 0.25 times 10 raised to power negative 3 sine into 500t minus 0.025x closed bracket. Now we are to determine the angular frequency of the wave motion. Now, before I go on to solve this, please, if you are not subscribed to the channel, I would like to implore you to please do so. As by subscribing, you're helping us to be able to make more helpful content like this. So please just take a second to click the subscribe button and also click the notification bell icon so that every time we put out a new content, you will be notified. And also don't forget to like, share, and subscribe. And also, if you have any question at all from what we have been doing so far, or if there's a question you were solving and you need help with it, you can just put that question in the comment section and we will definitely attend to your question. So now let's get to this question and put out what we have. So remember, the question is asking us to find the angular frequency. Now angular frequency is denoted W. Now normal wave of a progressive wave, the equation of a progressive wave rather, traveling in the positive x direction is given as y equals a sine wt minus kx. Now where w is same thing as 2 pi f and the k is the same thing as 2 pi over lambda. Now, since it's w we are looking for, we will compare this to the equation of the wave we are given. So we compare with, now the equation we are given, which says y equals 0.25 times 10 raised to the power minus 3, then sine 500t minus 0.025x close bracket. Now, from this, we can begin to pick out some things like, for example, the amplitude of the wave A is going to be what we have here. So if it's an amplitude we're asked to find, we'll say it's 0.25 times 10 raised to the power minus 3, right? Which should have been option A if we're asked to find the amplitude. But amplitude is not in rad per second, so please take note of that. But in this case, is the angular frequency we are to find, so which is W. So we're going to compare this equation, that is Wt is supposed to be 500t. So T cancels T, so W equals 500 rad per second. Now, when we look at the options, we see they are in standard form. So we can rewrite this as 5 times 10 raised to the power 2 rad per second. And that is option C. During a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as, now, there are quite a number of questions that can be said using thunderstorm as the basis of knowledge, right? And one of them is, like, for example, why is it that we see lightning before we hear thunder? And that one would be that is because the speed of light is way faster than the speed of sound. Even though lightning and that thunder that we hear happens at the same time, but because of the speed at which light travels, which is very much faster than the speed of sound, we see that lightning first before we then hear the thunder. And that sound that you hear during thunder, it's not exactly like that. But because it is reflected over and over and then it continues to resound, that is why you see it lasting that long period of time, despite the fact that lightning is just for a short period of time. Now, that phenomenon is called reverberation. So the answer to this question is D. A progressive wave is represented by this equation here, and then we are asked then it said two layers of the wave are separated by this distance 153 centimeters, and we should find the phase difference. So to find the phase difference in this case, this is what we're going to do. First, we need to find the wavelength because we already have, now note this, phase difference is 2 pi x over lambda. Okay, it's the same thing as what we know as kx. Okay, so applying this, we need to first find the value of lambda. So we would say, when we compare this with the regular equation of a progressive wave. Now let me do that at this point. A regular progressive wave says y equals a sine then wt minus kx, or we just say y equals a sine 2 pi ft minus 2 pi x over lambda. So we can use this to find lambda by saying 2 pi x over lambda equals what we have here, which is pi x over 34. So from here we can say lambda equals, remember pi x cancels out, so 2 times 34, and that will give us 68. Okay, so now that we have lambda, we can then go on to find the phase difference. So the phase difference will therefore be 2 pi. Now x is, they are separated by 153 centimeters, and then we divide this by lambda, which is 68. So working with this, when we resolve this, we're going to have 4.5 pi, and taking pi as 180 degrees, this can then be resolved as 810 degrees. This is the phase difference. But when we are working with the phase angle, we're going to work this divided by 360 and then write the remainder. So 810 degrees divided by 360, that would give us 2 remainder 90. So if we're looking at the phase point of this angle, of these two waves rather, we'll then get it as 90 degrees, which makes our answer option C. The wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is the period? Now, in this case like this, the period is denoted T, and the relationship between period and frequency is that period equals the reciprocal of frequency. So if V equals F lambda, it implies that the same thing is equals to lambda over T, right? So to make T the subject, T would then be V so if V rather equals lambda over T, T would then be lambda over V. So let's work with this. Now the wavelength is given as 42 meters. Now divide this by the velocity. The velocity is 420 meters per second. Meter cancelled meter. So period becomes, now 42 here 1, 42 here is 10. So 1 over 10 will give us 0.1. And when per second goes up, it becomes second. So our answer is 0.1 second, which is option D. Now, you can practice with many more questions like this on the Exam Fun app, which is created in a way to make your learning experience very much fun. So please click the link in the description box to download the Exam Fun app, either on Google Play Store or on the Apple Store, depending on your own device. When you click that link, it will take you to the App Store for your device to download the app. So register and download and register, and then have fun while you learn. And also do not forget to subscribe to the channel and also share our videos. And in case you have any question on what we have been doing so far, or if you come across a question during your study time that you need our help with, please drop it in the comment section and we'll definitely attend to your questions. Thank you for following the series so far. I'll see you in the next video.